Other way to think about rational exponents is you can think of this word as fractional exponents if you want. Okay, fractional if you will.
Stop making another meme.
No. Okay, that's another way to think of this. What's going to happen in this section is we're going to look at how to interpret a power that is a fraction and what to do with that and how it's related to radicals. Alright, so here's 3 examples, and I want you to pay attention to what's happening from the left where it's in radical form and the right when it's in rational exponent form. These two are equivalent to each other. The left side equals the right side. So what you have over here on the right is an alternative way of expressing these radicals. And the form that you're going to see in the book is going to look like this in general. Okay? So when I have an exponent, the top number is actually the power of the number inside. Now obviously these are all ones, which means this is 25 to the first, 27 to the first, 81 to the first, which is why you don't see it written in. And notice here that I put the little 2 in for the square root in this case. The denominator of the power corresponds to the index of the radical. Okay, and on this next slide you can see where all the little ones come from. We don't write the ones inside, but that's the same thing. Now in some examples, this number on top is not going to be 1, which means this number inside is not going to be 1. So we're going to have something different written down. Right. So some of the questions you're going to have are going to look like this. Write x to the 1/6 in radical form. So go ahead. This is exponential form. So just go ahead and turn that into a radical. Okay, what does this 6 represent? The index. This is the index. This is the root. We're taking the 6th root. The 1 indicates the power that we raise the radicand to. So what you should have had was this. If you put the 1 in, that's fine, but you don't have to. How many had that? Okay, that's all I want to start doing for now, is get you used to the idea of transferring between radicals and fractional or rational exponents. Okay, let's look at the next one. Okay, now the reason that I've written this over here, because this is what we had originally, notice up here I slid the power outside. Okay, these two things are equivalent. So you have some options. So go ahead and write this one out, but don't figure it out yet. Just write it out, and I want to show you there's actually 2 ways to write this. You could use it this way, the way we just did, or we could do it this way. And I'm going to show you both because I want you to see that sometimes it's easier to do it this way than this way. Okay? Now you're never going to have to write both of them out. I'm going to show you both, but I'm going to show you both because some of you may find figuring it out easier one way versus the other way. So here's what it looks like with both of them. Okay, so this was the original way, where we have the 8 squared, the cube root of the 8 squared, or we have the cube root of 8 and then we figure out what this is and square it. The reason why this one sometimes is a little more useful is it keeps my numbers smaller, and it might make being able to do it in my head easier. See over here,
64,
that's the 4th root of 64. Now, maybe you, or sorry, the 3rd root of 64. Maybe you know the cube root of 64. Maybe you do. I don't know. Okay? I would say it's probably more likely that you'll know the cube root of 8. Okay, what is the cube root of 8? 2. And so this is 2 squared. Now, either way, I get 4. It's the same problem. My point is, you can choose which one you like better. Okay, and from any given problem, it might change. Some cases, this way might be easier for you. Other cases, this way might be easier for you. Here's something I want you to hear loud and clear. When you do this on a test, you cannot just punch this in the calculator. It's going to tell you to convert to radical form and then evaluate. So you are going to have to write one of these two down. If you did write 8 to the 2/3 in your calculator, you'll get 4. It'll do it for you. There's no secret there. Alright? But the directions most of the time will say something like convert to radical form and then evaluate. So you just got to be careful when you're doing that. Are there any questions on that? Alright, let's do another one. Go ahead and do that one. Convert to radical form first, and then figure out the answer. Okay, so when we do this, you're going to set it up one of two ways. Okay, notice on the left, it's going to require that I'm going to have to cube 16, which is going to give me a fairly large number. Okay, on the right, it might be simpler to figure this part out first, because can you figure out what the 4th root of 16 is? What is it? 2. Okay, so it does save you a little bit of work in terms of doing it in your head. It's 2 to the 3rd, which is just 8. At the same time, I would not expect you to know what the 4th root of 4096 is. If you choose this way over here, you're going to really be using your calculator more than anything. There's nothing wrong with that. But if you want to save yourself a little bit of time, doing this part first will allow you to do most of it in your head, which usually saves you some time. Okay?
Is this the only thing we're going to learn today?
No, this is just the beginning of it. Okay? Are there any questions on this?
So basically we take 16.
Let's talk about some other things that you're going to see. Okay? You're going to see things like this, where you have multiplication of exponents, same base, different powers, and those powers are going to be fractions. Our power rules that we already know still apply. When I'm multiplying exponents that have the same base, what do you do with the powers?
Add them.
You add them. So in this case, we're still going to do that. Just because the powers are fractions, the exponent rules don't change. Okay? So when I do this, I'm going to combine the bases and add the powers. Okay? So what do I get when I have 2 sevenths plus 4 sevenths? 6 sevenths. So my final answer here is a to the 6 sevenths. Now, one of the things I want you to think about, and you're going to have to pay attention to the directions, but like in this problem, it doesn't tell me anything. So you're like, all right, do I put it in fractional power form, rational exponent form, or do I turn it into a radical? And the answer is you stay consistent. The problem started off with rational exponents. My answer should end up with rational exponents. So you keep that consistency like we've talked about in the past. Did the problem have decimals in it? My answer should have decimals in it. The problem have fractions in it? My answer should have fractions in it. If the beginning of this problem started off with radicals, my final answer should have radicals. So stay consistent unless the directions tell you otherwise. Okay? That's the answer. That's it. Yep. Okay. We can also do power to a power. So when we have power to a power, what do we do with the powers?
Divide. Subtract.
Multiply. Power to a power is multiply. So those rules still apply here. Okay? So go ahead and apply that power rule to a situation like this with rational exponents. Again, the rule doesn't change. It just so happens that the powers are fractions. So what is negative 2/5 times 1/2? Negative 1/5. What is 1/3 times 1/2? 1/6. So my starting point gets me to here. Okay, x to the negative 1/5, y to the 1/6. Again, all I'm doing is multiplying the powers. No, that is not it. What's the problem here? Well, I have 2 variables. That's not a big deal. That's not a problem. Negative power. We can't have a negative power.
Ah, get that puppy down below.
Which is why I have this bar here. So where does this go? What do I do with this?
Oh, you flipped that puppy.
I just take the whole thing and slide it down, and then the power becomes positive. Okay? So I get y to the 1/6 over x to the 1/5.
Let's go.
Am I done now?
Absolutely. Absolutely not.
We are not done now. Why are we not done now? When we moved this down, what does this really mean I have in the denominator?
Fraction.
No,
Exponent.
I have a fractional exponent, but what does this represent?
A variable
Fraction.
in the denominator.
Variable in the denominator is not a problem.
You can have fraction in the denominator.
Quadratic
I
formula.
just said that.
You can have a fraction in a denominator.
A negative.
What does this really mean?
Variable. I don't know.
Oh, I know what it is. I know what it is. Don't tell me.
Constant.
A square root in the
What
denominator.
is
There is a radical in the denominator. Okay, this means the 5th root of x. We cannot have radicals in denominators. Okay?
times by 5?
So here's our dilemma. Since I really have a radical now in the denominator, I need to rationalize the denominator. But I'm not going to change this to the 5th root of x. We're going to understand that that's what it is. What I need to do is make sure that I don't have a power that is a fraction. I want it to be a whole number. And the closest whole number to 1/5 is 1. Okay? So, I need to multiply x to the 1/5 by something to turn it into x to the 1st. So, let's think about this for a second. I need this to eventually equal x to the 1st. Okay, so think about our power rules for a second. What would I have to multiply x to the 1/5 by to turn it into x to the 1st? Don't say it. Just think about it for a second. What, again, here's the question. What would I have to multiply x to the 1/5 by to turn it into x to the 1st? Now think about your power rules and what we just talked about. Okay? In order for this to turn into 1, I'm going to have to multiply by x to some power. What will that power have to be?
X to the 5th.
X to the 5th will not work.
Why?
Because what is 1/5 times, or plus 5?
Oh, 4 over 5.
Okay, so if this was x to the 4/5, see, if this was x to the 5th, then 1/5 plus 5 is 5 1/5. It's still a fraction. But if this was x to the 4/5, 1/5 plus 4/5 equals 1. So what I'm going to really want to do here is I'm going to multiply top and bottom by x to the 4/5. Because thinking about our power rules, when I have the same base, I add the powers. And by adding the powers down here, 1/5 plus 4/5, that gives me 1. Which means I will have an x in the denominator without being raised to a fraction, which means I no longer have a radical. Okay? And so when you go to rationalize denominators with rational exponents, your goal is to try to turn the power into a whole number. And you want it to be the smallest whole number that's not 0. So sometimes it's going to be 1, sometimes it might be 2, but most of the time it's going to be 1. Now my final answer then, okay, I'm going to rewrite, I'm going to put it in alphabetical order. So I'm going to put the x first, x to the 4/5, y to the 1/6, all over x to the 1st, and we don't need to write the 1. So that's simplest form. No radicals in denominators. I can still be left with fractional powers. Okay, but understand how this is all connected to things we've done in the past. Power to a power, multiplied the powers. Negative exponents, slide it down to the denominator. Rationalizing exponents, make sure that I don't have radicals in the denominator when I'm done. So we've connected several different things that we've done in the past. Okay. All right, let's look at a couple more types of problems. Any questions before we move on to the next type of problem? Okay, So what power rule haven't we used yet?
Subtracting.
Subtracting, and when you have subtracting, what do you, that's division, okay? So here's the next kind of problem that we can deal with division. In order to use our power rules with division, the bases have to be the same. And in this case, I could write this as 16 to the 1/6 and 2 to the 1/3, but the bases are different, right? Because if the base for the top one would be 16, the base for the bottom would be 2, I can't use my power rules there. So one of the things that you want to try to look for is to figure out a way to make your top and bottom or your two different powers have the same base. And the way to do that is to try to make all of the bases the smaller number. And here's what I mean by that. Okay. Is there a way to write 16, since 2 is smaller than 16, is there a way to write 16 as 2 to some power?
Yeah.
Yes.
What would that be?
2 to the 4.
Okay, so this is 2 to the 4th. So what that ends up looking like, if I rewrote this problem, it would look like this. Okay, 2 to the 4th, which is 16. Okay, I just rewrote that.
Oh, okay.
Okay, I just rewrote that. And that red line is just dividing them, you know, separating the top from the bottom. It's not a giant fraction. It's just like a, it's just like a separator. Okay, separating the two parts. Okay. But now what I've accomplished is inside the radical I can have the same base, because now I can rewrite this as a rational exponent with the base of 2, and I can write this as a rational exponent with a base of 2. Okay? So what is that going to be? What's the top going to be as a rational exponent?
2 over 2 4 over x. 2 to 1 4.
2 to 4, 6.
2 to the 4 over 6, and then 2 to the
1/3.
1/3. Okay? So when I write them as rational exponents with the same base, we're just working it the other direction. We spent some problems earlier going from this to this. We can go the other way too. So it works both directions. I can go from radical to exponential form, which actually that's how we started. The very first problems that I showed you on the screen went from here to here, and we can go the other direction too. Now, so when I have division and the bases are the same, what do I do with the powers? Subtract. You have a question?
I was gonna ask, wouldn't you make the 4 over 6 to 2 over 3?
How about there? Yes, ma'am, we would. Okay, so I put this in a different color just to show that I reduced that. And now because of that, so again, since it's division, and again, this is not a giant fraction bar, it's just a separator.
Yeah, that's sketching me.
Okay, so what's 2/3 minus 1/3?
1/3.
1/3. Okay, so I get 2 to the 1/3. Can I stop? Should I just leave it there?
You can keep going.
I mean, I can't simplify it anymore. So before you decide to move on to the next problem, you go, all right, how did the problem start off? What did we start off in?
Radical.
Radical. So what do you think I need to do?
Radical.
Make it a radical. So what is that?
3 square root of 2.
No. Cube root of 2. Cube root of 2. The square root only, you only say square root when either there's nothing here or this is a 2. This is the cube root of 2. Okay? Questions on that?
Wait, I'm confused.
So I know when you look at it with numbers, you think the 2's cancel out. If these were x's, you wouldn't cancel the x's out. You'd put an x there and you subtract the powers. It's the same way when the base is a number. And the truth is, this type of problem will only happen with numbers because we're trying to change the bases to match up. Okay?
So I'll never cancel the number.
No, you never cancel the numbers. You copy the base, subtract the powers, even if the base is a number.